Good morning. My name is Myroslav Mishov. I'm a private cloud infrastructure architect, SRE, and Kubernetes. For over 16 years, I've been running on-premise infrastructures, basically ranging from clients like manufacturers, retailers, healthcare, and up to government agencies. So everything must be on-premise, secure, and fine. So in this session, I will not talk about AI. Yes, it's vibe currently, but so I will tell about AI on the upper level. I will focus on the infrastructure. So in real world, all containers future reality hasn't arrived. Many companies still rely heavily on VMs, on the virtualization, whatever is it, Broadcom, OpenStack, any other. And we're going to discuss how to actually break free from the legacy virtualization infrastructure and move everything to Kubernetes. Before we start, I want to set context for who this presentation is really for. So if you are an infrastructure engineer or platform architect or a technical leader who is actually owning it, building it, managing it, or paying bills for the enterprise virtualization, this talk is for you. The ask from my client was to help them break free from Broadcom, from the legacy virtualization. The licensing cost was skyrocketing. Another issue was it was killing the developer velocity and drained budget for the business. They were focused to fund two separate teams, one to run and maintain the fancy new modern apps and AI, and another team just to keep up with virtualization layer itself. When evaluating the legacy footprint, the biggest realization was how far the client has been left behind. Developers today expect experience close to public clouds. They want instant, declarative self-service. Instead, they were forced to the ClickOps and manual operations in traditional UI. The team spent months building the custom integrations for automation, only to have one minor update changing API to break this out. There was no real way for GitOps or declarative state management. Honestly, it felt like they were captured in the Stone Age, while the rest of the world has been moved forward. We had to close this gap to help them move to the new platform and keep this completely on-premise. So as this client is heavily rely on VMs, they run thousands, to replace the virtualization. First we naturally look at OpenStack. So it works great for huge companies who have spent decades polishing their polishing the operations. So I had drafted the roadmap and almost started the POC to migrate the first batch of VMs to the OpenStack, but I stopped. The operational complexity was prohibitive for the client, and likely for many of you here. To transition as successfully, it would require a massive upskilling effort or hire a completely new virtualization team just to keep up with the infrastructure. So I wanted a better future for the client. So we decided to switch back to what we knew and truly love, the Kubernetes. So how would you run VMs in Kubernetes? Kubevirt, right? So it's an incredible mediator between Kubernetes and battle-tested Linux KVM virtualization. And so the ability to run VMs as pods was exactly the feature that we needed. But there was a catch. Kubevirt is an incredible engine, but it is not a complete platform a large enterprise would need. So when you're building a cloud for enterprise, to meet the modern needs, you would have to solve multi-tenancy, strict isolation between departments, teams, and as deep as to per application, and provide simple as a self-service. After rolling out the OpenStack, we evaluated the rest of the market landscape. On the left, you can see great enterprise solutions like OpenShift virtualization and Nutanix. They are great platforms, but strategically it felt like we were trading Broadcom licensing for IBM or Nutanix vendor lock-in. It would defeat the purpose of building truly sovereign cloud if a client cannot own parts of it. On the right side, you see a few open source alternatives. Proxmox is popular in SMB space. Harvester is another great choice, but the issue with Harvester was that it relies heavily on Longhorn for storage that has latency issues. So it cannot provide you microseconds. So I will see at least a half millisecond or 1 millisecond latency. To be honest, evaluating solutions took quite some time. Then CozyStack emerged as a most promising open source solution at the moment. So here I will use it as a reference platform, so I'm not affiliated with them. So it really is a dynamic open source sandbox project. Yeah. So it has the architecture we were trying to build, and solving the multi-tenancy isolation out of the box. So it actually simplified our roadmap. By adopting this, we eliminate the platform tags completely. Developers log into a single cloud-like interface or command line, and so they can provision managed Kubernetes clusters. So right aside of VMs for legacy application, or request managed DB clusters or other application clusters that are benefiting of running on the bare metal with real bare metal performance. And all of this is managed by the same declarative Kubernetes API and the GitOps. So another pain point for the client was actually the latency, the storage latency. So on the Broadcom vSAN provided them like half millisecond to 2 milliseconds storage latency. So in new environment, we use a lean store for block storage natively on Kubernetes. We removed the vSAN storage tags completely, and the vSAN licensing cost. In our testing, we were hitting 30 to 80 microsecond storage latency and 3 to 7 gigabyte per second throughput. We are delivering real bare metal storage performance directly to the database clusters, VMs, and AI workloads. You may say virtualization is old and fine. How about modern challenges like AI? Yeah, so in the beginning, I promised you not to tell about AI. I will not touch it. So I will stay on the underlying platform to actually run it. So in the traditional environment, costly GPUs are trapped. So on the unified fabric, they are fluid. We can dynamically pass through GPUs to tenant Kubernetes clusters for inference, or attached to VMs for heavy batch processing. Maximum flexibility, utilization, and zero friction. So I see hardware as a pool of primitives managed by reconciliation loops, GitOps, and not static manual assignments. So we discussed the architecture and performance, but none of this matter if developers can't use it. So we promised them a public cloud experience. Here we hide the complexity of Kubernetes, MetalB, lean store, autoscalers, behind a simple cloud-like self-service portal. Developers get the feature of the public cloud, and your CISO and compliance teams are happy that you are keeping your data local on-premise. And here's another example on how to move away from manual ClickOps in UI and shift to GitOps or command line for declarative management. So on the left we've defined our infrastructure as code with FlexCD. So instead of a series of manual tickets, we configure a Git repository to act as our source of truth, and voila. Once these manifests are applied, the platform takes over. To the right, you see the result of the reconciliation. The system has automatically deployed an isolated namespace with Cilium network policies, so inside this isolated namespace, so it provisioned a Postgres cluster, Kubernetes, so managed Kubernetes cluster, also one Ubuntu desktop virtual machine, so just to show the same for VMs. So, and so here you can see you can get kubeconfig for your new managed Kubernetes cluster and start using it. This isn't theory, so right now I am running a POC and preparing for the production implementation for the client, for this unified control plane. By doing this, we are helping the enterprise escape what I call the legacy trap. To give them the total control of the data, the code, the infrastructure, the security, without any vendor lock-in. So it is a practical proof how Kubernetes nowadays can handle like everything, including bare metal, hardware, the mission critical traditional workloads, modern apps, AI, so whatever comes next. Getting the bare metal on-premise cloud to behave like a public cloud is a huge milestone and may be fine for many companies. But for clients in regulated industries, functional is not enough. We have to bridge the gap between functioning platform, MVP, and fully compliant platform company can run in production. The points here are a high-level blueprint of my framework, sovereign edge compliant orchestration. Establishing this strict provable baseline is non-negotiable for clients in any regulated industry like healthcare, FinOps, government. So a lockdown, the foundation, is a basic for the trust. So, and here just a few examples how to get parts of it together. How much time do I have? Good. So, first the hardware level, the hardware and network level. 5 minutes? Okay. So I have to skip it. So here is how to actually do the migration. So in real enterprise world, you don't start from scratch. You have hundreds, thousands of your existing VMs, and you would like to shift them to new platform. So you cannot rely on manual redeployment, reconfiguration. You have to just shift them together. So this is what the current blueprint actually looks like. A simple a simple control plane for everything, and an operational velocity with declarative GitOps, and absolute ownership of your data, of your code, of your security, your infrastructure, everything. And yes, you are saving costs. I know some of you in this room may be dealing with challenges like this at the moment. Some may be wrestling with OpenStack complexity, or trying breaking through the traditional virtualization. So dealing with all of this may be hard, and so that's why I'm here, and I'm happy to help you with this journey. Thank you, everyone.